that's
Take it away.
alrighty. So yeah, we're going to talk about device mount sensor credentials today. I'll explain what in particular I mean. Chopped off.
What's that gray box?
I thought it was a security like
The cameras.
That's like,
This has been redacted.
the camera. Can I minimize? That'll get it smaller.
Okay.
Huh. Oh. Okay, it's being recorded. We can get rid of another gray box.
But the Zoom stuff, wow,
It's weird.
These are Zoom things that are.
Yeah, they're doing
Yeah.
things.
So that
But you can't look at that yet.
yeah.
Okay, well, that's what you get.
That's fine.
Good titles anyway.
It looks elite.
Okay, yeah, that doesn't matter. All right, so the reason I want to start our discussion with this little Telegram chat that I ran into. I was lurking in a channel that I discovered through the Conti leaks. I don't know if anybody remembers that. Anyway, it was a ransomware group and somebody got mad and dumped 2 years of their chat logs, which was very interesting reading. Anyway, so I've been lurking in this channel for a couple of months. And one day, over a couple of weeks, it kind of shifted into the entry area for a dark web marketplace, right? So this was people would come here and say, oh, I want to get access to the place where I would actually buy stolen credentials, things like that, right? And so I did not go to the next step and request that. But I was surprised to have this come in and somebody's like, hey, I want to sell stuff. Obviously, I had no connection with the group before. And their response was, well, what do you want to sell? He's like, I've got cookies. I thought, well, that's weird. Like, I knew people sold cookies, but generally you think about selling passwords, right? But there is a market for stolen cookies, right?
Yeah.
And that happens typically, like TLS is good. People are not usually stealing cookies over the wire. So it's either JavaScript vulnerabilities, cross-site scripting, or it's info stealers where they actually compromise the laptop or the desktop and then scrape the cookies directly out of your browser. So we would like this not to be a thing as good security defenders. And so the question we want to talk about is how do we keep session tokens from being sold on the dark web, right? So the obvious solution here is just to stomp out all JavaScript vulnerabilities and secure every system,
Well,
right?
that fixes it. Okay, done. All right, good.
Okay, so since that is not going to happen this week, we've got a plan B. So as defenders, we are, it's convenient for us that cross-device cookies are not a thing. Every time I log in on my laptop, like it's a new laptop, I expect to put in my username and password, I get a cookie or a session token. I'll kind of interchange those. And then if I go to my phone, I don't expect my phone to know anything about what's going on my laptop, right? So once that session token has been issued, mentally, we have bound it to the device, like that session is associated with the device, but technically it's not, right? If I take that, drop it into my browser, like if I took the cookie off Heidi's phone and put it on my phone, then I could log into or go to the website and the website would think that I was Heidi, right? But what if we could have the server know which device was sending the cookie and which device it issued the cookie to, and then it could say, oh, that's a stolen cookie, and reject it. So the simple approach to this is like, great, we'll just log the IP address, right? Doesn't work. It actually works a lot, but not perfectly, and so we can't rely on that defense. There's clever techniques of looking at which request headers get sent, depending on the browser and the platform. Like there's different things you can pick up on. But if we got serious about that, the attackers would just steal your request or your headers basically as well, and you can send them both. There's some really interesting stuff that you can do with profiling the device, but that very quickly crosses over into the things that the people who are trying to track you across websites are doing, right? So it becomes a privacy issue. So we can take advantage of a brand new feature, okay, last decade's feature of the TPM, the Trusted Platform Module. So if you're not familiar, this is a hardware chip. It resides on your phone, your laptop, your desktop. You have to have one to run Windows 11 now. And its role in the universe is to generate public and private key pairs, and it'll give you the public key, but it will never give you the private key. There are tricks around that, but they're hard. And then you feed data to this TPM and it encrypts it for you, and then you can set that off. So some brilliant people at Microsoft back in 2016 came up with this idea of token binding. And the picture is better than the words, so let's go to the picture. So sort of forget for a second references to TLS. The idea is pretty simple. You start a session and the server sends a special header that says, I want to use your TPM. The browser knows what to do with that. And so it calls the TPM, gets a public key, gives it to the server, and then the server records that as part of the session. So that's initiation. And then on subsequent, oh, well, that animation didn't work. On subsequent calls, the server requires the client or the browser to encrypt something with that private key, and then it decrypts it. And that way it knows this must have come from that device, right? That's the design. So the question was, what are we going to encrypt? And the people at Microsoft thought that, well, we've already solved this problem. Your TLS session, when you're establishing that encryption between the client and the server, goes through a negotiation to pick some random constants, right? And so they're like, well, we already have these secrets that are protected by TLS. The client knows it, the server knows it, nobody in between knows it. So let's encrypt that. So your TLS constants are what they wanted to do. So, question for developers, what part of your stack handles the TLS connection? And if you would name a piece of software. So 2
Is
seconds.
that kernel doing the TCP stack? Or is it higher than that?
Higher than that.
Yeah.
But it's going to be the web server, right? So Nginx, Unicorn, Apache level. That's the code that's going to implement that, because encryption is hard and you should never write it yourself. Now, who's responsible for doing the session? The app server, right? So probably middleware, might be Rails, might be some other piece of middleware. Sometimes you write that yourself, although you do that at your own peril as well. It's hard to get TLS information like that out of the web server. And that turned out to be too high a hurdle. And so this token binding faded and isn't really a thing anymore. So Google came up with their swing. This was released about 2 years ago. Again, words are boring. Let's do pictures. It's very similar. Google's implementation actually starts after the credentials have been authenticated. So when you submit your password, finish your 2FA, because we all use 2FA, then the web server replies with a special header. And basically, but the header includes a challenge. So we're not trying to predict constants here. The server just makes up some random numbers because that's fine. And so that goes back, the client submits the public key again. And like, because this is all going over the same TLS section, we know that that's the right person, right? The right client. So one interesting thing, this is the header that comes back from the server. And this is interesting. So part of Google's implementation is a couple of paths that the middleware has to implement. And this lets you tie in your session handling at this point. So I give you an endpoint called start session, or whatever you want to name it. And then there's a challenge there, and there's an off code. And so now you take that, you do your encryption, and you send me your public key the first time and the encrypted portion. Okay. And then the server responds with a traditional session token, right? We're going to pretend it's a cookie because cookies are better than JWTs. So you have that token, and this is the tricky thing. Google decided that the browser should take over session refresh. So it knows when this cookie expires, and then it calls this other endpoint, which was in the response. I've got the box here somewhere. There it is, the refresh URL. And so now your browser automatically calls that every 5 minutes in their demo code, right? And so the browser always maintains that session. And it, knows how to talk to the GPM. And so from the user side, they're none the wiser. This is fine. From the server side, you have to do, or I guess these are the summaries, right? The browser recognizes the header, the browser sets up the server or the token, and then the server must implement those two endpoints, and the browser handles all that refresh, right? So that's kind of the way this works. So
That's my next question.
right? So Chrome has implemented this. Firefox and Safari say they're thinking about it. They're part of it's like there's a formal W3C proposal about this. Google has published demonstration websites, but when I say Google, as I was diving into this, it's really free people. And they haven't put out any server code yet. And so the reality is, it's mostly credits. So could this catch on? Absolutely. It's starting to feel like it's not going to, right? It's been 2 years. But hopefully you've enjoyed this quick 10 minutes, 10-ish minutes for the design challenge. And it feels like another proposal might simplify things just a little bit, or somebody will get behind this and it'll happen. Questions?
Could it be done as an extension that you could opt in to add to Chrome or something?
Yeah,
Oh,
and
and
then you could
separate.
require your, like, if you're like a high security, like, say you're giving this talking, like, is this how the NPM do for accident? Got hacked, so it's a long-lived token that was replayed. And I'm like, that's exactly the vector, so I could imagine like if, so we're GitHub, like,
You never
we could require for, say, we do like a pseudo check. We could require you to install a browser extension for super high security, like if you're a maintainer of like a repo with more than 100 million downloads a week or something like that.
Your challenge would be that the extension would have to talk to the platform or the devices.
Right.
Oh,
Right.
So that's a little.
It's probably better to just require 2FA, which was with the Axios.
Now, what would be interesting if someone with GitHub's weight came along and said, hey, Google, we'd like to implement this.
Right.
That might be the nudge it needs, right? But,
Do you have any records in your research of this being used, like how this exploit has been used for this, like, because I'm still for
This
sale.
mechanism?
Yeah.
Oh,
Yeah.
the cookies,
Yeah, are there any famous cases where this was used?
Like supply chain.
I don't know for sure.
Interesting stuff.
Well, if cookie was the mechanism of compromising the supply chain attack, that's the question.
Yeah.
I don't know for sure. I haven't looked at that.
How fast is the TPM? Because if you're doing this every web request.
So you would,
Or at least every handshake.
it's only on token refresh.
Oh, okay, all right.
So
How long does it take those? Are they fast enough?
I think that the reason it's done as a separate token is because you wouldn't want to do it on every request. But it's a very small piece of data, so it's gonna be mostly negligible.
Okay. And you also offhand said cookies are better than JWTs.
Well, we
I'm
could
curious.
fight about that another day, but but it boils down to, my opinion is that the browsers have invested a lot of time in protecting cookies
Mhm.
and keeping them isolated from JavaScript.
Yeah.
And usually JWTs are implemented within the client-side code, like the client-side
Okay,
code
so
has
it's
to
just-
success.
It's just there in a variable or whatever.
Yeah, exactly.
Yeah, okay.
And so that exposes it in a way that you don't need to. Now, you can absolutely take the JWT format and make that a cookie,
Mhm.
fine. The other problem with them is that when you log out, you have a hard time killing them, like
Right. 'Cause
logging
there's
out.
no- There's no
because it's-
expiration unless you also do a refresh and right.
Exactly,
Yeah.
exactly. So I'll end it there because
Cool.
there's more talking.
That's great.
All right, thank you. That's it.
Thanks. Awesome. Thank you, Mark.
How do you want to deal with this, Ron?
Well, I can hand this to you if you wanted.
Well, do you want me to like be on Zoom or?